Hello, in our last 5 lessons, we have introduced the vectors. Vectors means it has a magnitude and also direction. And also we have done the operations of vectors, adding, subtracting, dot product, and cross product. So in this lesson, we are going to do the application. So force as a vector. Force, we know it has a magnitude and also it has a direction. So force is a vector. And we have several terms you need to know. So the first one is resultant. Resultant of forces is just kind of the sum of the forces, and we call it resultant force. So in physics, we call it the net force. So the net force is our resultant force. And from Newton's second law, why we want to know the net force? Because it's connected with the acceleration. So equals m, the mass, times the acceleration. And the resultant of several forces is one force, a single force, that can be used to represent the combined effect of all the forces. The individual forces that make up the resultant are referred as the components of the resultant. So the net force, maybe we just have this direction, and this is our net force. We call it resultant force. So equilibrant of several forces is a single force that opposite to this resultant force. So we draw it backward. And same magnitude, we call this is equilibrant. And if the equilibrant force is applied to one object, then you will see these two forces will be cancel each other. So the object will stay in a rest or keep moving at a constant speed, because the net force. So we may just change this one to just resultant, because now altogether we have the net force is 0. And this state we call equilibrium. So collinear forces are those forces that act along the same straight line, so same direction, either same direction or opposite. So we call them collinear. Okay. In general, the resultant and the equilibrant are two vectors having the same magnitude but pointing at opposite direction. So these are some terms you need to know. Then we are going to see for the forces how to find the resultant force. So there are two methods to draw the vectors, adding, subtracting. So for this one, if F1 plus F2, we could use a parallelogram, draw the parallelogram, then the opposite of these 2 points, the diagonal, is our resultant force. So this is our resultant force. And the equilibrant force is just opposite with this direction, the force, but equal to that force. Another way we can draw it is a tail height, then another vector, tail height. So the first tail to the last height is our resultant force, and the equilibrant force is just opposite with the resultant force. So now we are going to see one example. So example 1, connecting the resultant force to vector addition. So resultant force is just one single force combined all the forces effect together. So two forces of 20 N represent the unit for the force is Newton. And the 40 Newton act at an angle of 30 degrees to each other. It asks you to find the resultant of these two forces and the equilibrant force. So for this question, we are going to, you could use the trigonometry to find the resultant force using the sine law, cosine law, or we could use a component vector method. So we set up the x and y direction. So this is x, this is y, and for simplification we want to put one force on the x direction. So we put 20 Newton here, then the 40 Newton is 30 degrees, this is 30 degrees, and this is 40 Newton here. The resultant force, we know we could draw the parallelogram. Then from the opposite vertices, this is our final force. So we could use this is OA, this is OB, then this is OC. So we want to find the OC, that is our resultant force. So OA, we could write it as a component vector. So x direction is 20, y direction is nothing, so it's 20, 0. And for the OB, we know that we want to find the x direction and y x component and also y component. For that one, if we draw a right angle triangle here, so this is 30 degrees, this is 40. But in this right angle triangle, we know this is based on the 30 degrees, this is opposite, this is adjacent, and here is our hypotenuse. So we could use opposite over hypotenuse equals our sine 30 degrees, and the opposite for this one is our y. This is our y, and the adjacent is our x. So opposite is y, hypotenuse is 40. So we know that y equals, move the 40 to this side, we have y direction is 40 sine 30 degrees. And for the x direction, it's adjacent over hypotenuse. So adjacent over hypotenuse is equals, adjacent is x, hypotenuse is 40, and we know adjacent over hypotenuse is cosine 30 degrees. In order to solve for x, we move the 40 to other side, it's 40 times cosine 30 degrees. And in order to find the sum of these two, we know from the component vectors, what we need to know is just add the x direction together, y direction together. So we are going to have the sum of the OA plus OB give us OC is just 20 plus 40 cosine 30 degrees. Then y direction is 0 plus 40 sine 30 degrees. Then get our calculator out. We figure out it's around 54.64. Then the y direction is just 20. This is a component vector, and if we want to find the magnitude, the magnitude will be the x squared, y squared plus x squared. This is a squared plus b squared equals a hypotenuse squared. Then square root is our magnitude, so it's just square root x squared plus y squared, 54.64 squared plus 20 squared. Then get our calculator out, is around 58.2. And the angle between like 2, so I will rewrite this OC. This is not connected, so this is O and this is C. Okay, so angle is tangent inverse YOX, because this is OC, so YOX, opposite or adjacent, give us this angle. Then we sub in tangent inverse 20 over 54.64, so give us around 20.1. Okay, so this angle is 20.1 degrees. This is magnitude is 58.2. So, and the equilibrium. So the equilibrium force will give us the same magnitude. The unit is Newton and the angle will be opposite, so it will be opposite with this direction, will be here. So this is 20.1, so this is 20.1 degrees. So if we write it based on this 20 Newton force, it will give us, it will be 180 minus, so 180 minus 20.1 degrees is around 1, we could just 59.9, 159.9 degrees. So if we see, it will be away from these two forces, so it's clockwise. Okay, so this is that, and this didn't say that it's counterclockwise, so if we want to make it more precise, we need to say this is counterclockwise. Then we are going to know that the 159.9 will be the clockwise. Okay, so this is our final answer. This is our resultant. This is our equilibrium force. So this is for example 1. Then we are going to practice on more examples. So example 2, connecting forces to the components of a given vector, and from this example you are going to see now the components of a force has meanings. So Kayla pulls on a rope attached to her sleigh. Okay, so we have a sleigh here. The force is 200 Newton. If the rope makes an angle of 20 degrees with the horizontal, so if this is a surface, is horizontal, then the force is this direction, 20 degrees. And this is 20 Newton for the magnitude. The question asks you the force that pulls the sleigh forward. So if we set up the x and y axis, then the force that is on the forward direction is just one of the component vector for this 200 Newton. And this is x direction. We know this is adjacent over hypotenuse equals cosine 20 degrees. So question A, the force that is on the x direction is our force pulls the sleigh forward. and this is adjacent over hypotenuse equals cosine. So the adjacent equals hypotenuse times cosine. So x direction will be cosine if the angle is formed with x direction. So we do the calculation, we have around approximately 187.94 Newton. And for the B, the force that tends to lift the sleigh, it will be the force that is on the y direction, okay, on the y direction, and is equal to this opposite side. So opposite over hypotenuse equals sine 20. So opposite equals hypotenuse times sine 20. So the y direction equals the force times sine 20 degrees. Then get your calculator out. It's around 68.40 Newton. So you will see that the components vector, the x direction or y direction, the forces has meaning. So this is done for this one. And example 3. Selecting a strategy to solve a problem involving several forces. So this one, a mass of 20 kg is kilogram, is suspended from a ceiling. So we are going to sketch it. This is a ceiling. Then a mass, an object, is suspended from the ceiling by 2 lengths of rope that makes angle. One is 60 degrees, another one is 45 degrees. So I will redraw it. So 60. This angle is 60 and another one is 45. So here is an object, and for the free body diagram, so this is our tension. So this is our tension 1, and this is our tension 2, and here will be our gravitational force, the weight. So we have 3 forces here, and we want to draw the xy coordinate system. So this is x direction, and y is just a vertical direction. This is y direction. So determine the tension in each of the ropes. So we assume that it's in the equivalent, so the net force will be 0. So we want to find the x direction forces. So we have x direction, and also we have y direction forces. So we are going to write this one. The net force, use the net force equals 0 to set up equations in order to solve for the unknown. Our unknown is the T1 and the T2. Then we are going to see the T1. We have 3 forces. We write the x, y direction out. So this one 60 degrees, then this Z pattern. This one will be 60 degrees too. And for the x direction, for the T1, it will be cosine. So T1 is unknown, then cosine 60 is our x direction, and don't forget this is in the second quadrant, so x is negative. The T1 is magnitude, it is positive. So for the sine is for the y direction, it is opposite, is sine angle. then the T2. The T2 is in the first quadrant, both x and y will be positive. So this Z pattern again is 45 degrees formed with x axis. So we want to use the angle that is formed with horizontal, then if it's with horizontal, then the x direction, the component is always adjacent. We'll use a cosine of that angle. So T2 cosine 45. And for the y direction, it's just sine 45 degrees. And the third force is our gravitational force. Gravitational force, you will see x direction nothing, y direction is negative. Mass times the gravitational acceleration. And the gravitational acceleration, we know it is 9.8. This is a constant, meter per second squared. So the net force is 0. It means all the x direction add together will be 0. So we just write for x direction is negative T1 cosine 60 degrees plus T2 cosine 45 degrees. Then plus 0 give us 0. And y direction is T1 sine 60 degrees plus T2 sine 45 degrees. Then minus m times g. M times g is m is 20, g is 9.8, equals 0. So the equation 1, equation 2. Then from these two, this is a linear system because the variable is T1, T2, the degree is 1, so it's linear system. For linear system, we could use a substitution or elimination method. We know the special triangle cosine 45, sine 45, both of them will give us square root over 2, so they are equal. And for these two terms, we know that the number at front, they are same, so we could just subtract these two equations, and these two subtract will be 0. So this is what we want to do. Equation 1 minus equation 2. To get rid of, we call it elimination. Eliminate of one of the variable. Then we are going to have only one variable left. Then we can solve it. One equation with only one variable, we can solve it. If one equation with two variables, we don't know how to solve it unless it is a special case. So negative T1 cosine 60 degrees minus this T1 sine 60 degrees. T2 cosine 45, sine 45, they are equal, minus give you 0. Then minus negative 20, it will be plus 20 times 9.8 equals 0. So in order to solve for the T1, we are going to common factor the T1 out. So we could just common factor negative T1 out. Each term divided by negative T1, we have cosine 60 degrees plus sine 60 degrees. Then we could move the 20 times 190 times 9.8 to other side is negative 196. Now in order to solve for the T1, we could bring the negative cosine 60 plus sine 60 to other side. Then divided to both sides. The left side divided is 1, the right side use a calculator to find out. We are going to find T1 equals, so T1 equals 143.48 Newton. Then we are going to do a solve for T2. So we have two equations. We could use equation 1, equation 2. And from equation 1, equation 2, you will find out if we use equation 1, it's easier for us to solve for T2 than the equation 2 because we need to move this one to other side. For this one, we just move the negative T1 cosine 60 to other side. We could find the T2. So we just from T sub this one, T1 into equation 1. So we are going to have negative 143.48 times cosine 60 plus T2 cosine 45 equals 0. Then we want to solve for T2. We move this to other side, then bring the cosine 45 to other side. We are going to have T2 equals 143.48 cosine 60 degrees all over cosine 45. Then T2 is approximately 50.73 Newton. Okay, so in this question you will see you have more than two vectors forces. Then we just use x component balanced and y component balanced. Then we have two unknowns, we have a linear system. Then we could use elimination or substitution method. So elimination is just the number at front of one variable, same or opposite. If same, we subtract. If opposite, one positive, one negative, we add those two. Our goal is one equation with only one variable left, then we can solve it. So if one equation with one variable, then we are going to isolate that variable by moving the numbers to other side, doing opposite operation. This is multiplication. Then we divide this to both sides. Once we find one variable, we need to sub it back to find another variable. Okay. Then we are going to continue to do more applications. So this one is on the D2L, so it's under quizzes. We don't have the delta math practice. Our check your understanding will be on D2L under quizzes. So delta math doesn't have the vectors. Okay, so work. This is another application for the force. So work equals the force act on an object to move it to the direction of the force. So the W work is a scalar, equals the force times the displacement at the direction of force. If the displacement is vertical with a force, then no work is done. So it involves a projection of the force onto the displacement vector. So it means if this is displacement and if this is force, the work is the projection of the force on the displacement, then times it together. If this is angle theta, then we know this is adjacent, so the force equals amplitude of force times amplitude of the displacement, then times the cosine theta. So this is we call dot product. If it's cross product, then it will be sine theta, and the direction will be the right hand rule. So you just wrap your fingers from F to D, then it will be your thumb inside. So if you wrap your fingers from F to D, so your hand wrap your fingers in this direction, then your thumb will go inside. So it will be the direction for the cross product. But this one is dot product is a scalar, so it's not a cross product. So this one, a wagon is put a distance of 200 meters by a 160 Newton force applied at an angle of 20 degrees to the road. So if we draw the road, this positive direction, and this is 200 meters moved. The force is formed 20 degrees with displacement is 160 Newton. And in physics, your teacher may ask you to use a graph. So we are going to write it properly. So G represent given. So we are going to write given out. The force is 160 Newton, and the direction is 20 degree up, and the displacement is just 200 meters in the positive x direction. And required to find, R means required to find, is work done by the force. So A is analysis. So the formula, so which formula we are going to use is just the work equals force times displacement, and it is magnitude of force times magnitude of the displacement, then times the cosine angle theta. Then we sub in the given information is 160 times 200 times cosine 20 degrees. So get our calculator out. It is approximately 30,000 and 70.16 joules. This is a work unit, and the given information is just no decimal places, so we could just round it to 30,000 and 70 joules. Then this is our solution. Okay, this is a formula, and this is solved, and the last one is statement. So the work done by the force is 30,000 and 70 joules. Okay, so this is all for today's lesson, and what we have done is we use force as use the fact that the force is a vector, and we apply the vectors adding, subtracting, and multiplying to force. And we have several terms. Resultant force is a sum of the several forces. The combined effect of all forces is a single force, and the composition of forces are the components of the applied forces. Equilibrium force is opposite with a resultant force. So you could use a parallelogram to find the resultant force, or you could use tail height, the first tail to the last height to find the resultant force. Then we use a component vector method to find the resultant force. We use x squared plus y squared. If 3 dimension will be plus z squared, then square root to find the magnitude. The angle is just a tangent inverse y over x. And the equilibrium force is just same magnitude, then the direction is flipped from this direction to opposite. So the component force has meanings. So this is a force pulls the sleigh to the front, and also the force tend to lift the sleigh. And this is if more than one forces, we just find all the components, x component, y component. If no accelerations, then the net force will be 0. So all the x direction forces add together 0. All the y direction forces add together 0. Then if you have more than one variables, you may have a linear system. Then you use the elimination method or substitution method to solve. So I forgot the statement here, so you could write the statement. Therefore, tension 1 is 143.48 newtons, and the tension 2 is 50.73 Newton. Okay. And the last one is work. Is just a dot product of the force and the displacement. So it's a magnitude of force times magnitude of the displacement times cosine theta. So thanks for watching.